way for a nice introduction. And good morning to everyone from our Research, Development and Manufacturing Center of the cellular routers and gateways in Europe. My name is Pavel Pospíšil, and it's my great pleasure, together with Jan Otte, introduce our secure networking platform.
Hello everybody, my name is Jan, I'm from R&D, and I'm here to provide a little bit of technical help if needed. And please feel free to put your questions. We will try to answer all of them at the end of the presentation. And if we cannot answer something, we will provide responses via email.
Thank you. So let me begin with a little parallel between our daily life on network and chess game. Every day, every second, we are connected to the internet. We face attacks. Robot hackers doing all they can just to break the wall to get access to our hardware, to our data. This represents for us the dark side of the force, the dark side of our daily life on network, and as well as player of chess, think in advance, setting strategy. We want to make sure that we are ahead and the connected devices are protected, data are safe. So this is our little parallel between the chess game and how we behave and how we exist on the internet, on network. Our devices brings data from the various applications at the edge of the network. They connect your control rooms with the remote locations, whether they are stationary or in move. Connected via various interfaces like Ethernet, serial, digital I/O, Wi-Fi. They convert protocols. And to close the circle and bring the complete solution, we add, kind of as a cherry on the top, software tools which helps you manage and monitor your devices, manage networks you build, all in advanced and secure way. So usually, what typical scenarios of remote communications you see in your daily life? The first one, when you buy the SIM card and you are in the mobile network of the operators, you buy the standard non-public dynamic IP address, SIM card with non-public dynamic IP address. And kind of challenge here is actually that if you would like to go from the web server and you would like to reach the device, you're not able to reach the device all the time. The SIM card you have in your phone and so on with dynamic IP address from security reasons, that's the initiator of the communication. So the communication is initiated from the device itself, not from the web server. So if you are in a control room and you have somewhere in the substation, in a water treatment plant, if you have a camera with SIM card, you're not able to access from the web server the camera. The second case is the scenario when you have public dynamic static IP, DIN, DNS communication, type of communication. The thing is that, yes, there is address, you can access the device, and this address is publicly shown on the internet. What's happening here that it's exposed to everyone, to the machine, to the hackers, and you get a lot of unwanted traffic. Everyone knocks the door. This can lead easily that you exhaust like 2 gigs or 3 gigs in a day. Within a day, your data are gone. So how you can answer these two cases is actually the private APN. The private APN is offered by carriers. Disadvantage of this, okay, it's secured. Disadvantage is that you are tied to the carrier, the one provider, the one third party. It's costly, obviously it's costly. And the challenge could be if you go out of your country. So if you want to go out of your country, different carriers, you go from US to Canada, Mexico, LATAM, Europe, then you face roaming and other challenges. Another solution could be the VPN client server. Then, yes, you have a secured tunnel established between your SCADA server and your client. The challenge here is that it's basically point-to-point communication. It requires high knowledge, so you need to be skilled to set it. And there are like 80% of real-life application. When you really need like a very skilled IT person, you need the resources to overcome the setting of the both ends of the tunnel. I'll answer this, how to connect the devices, how you initiate the communication, how you read your devices at the edge of the network, is actually the WebAccess VPN solution. What are the key advantages we see here? And it's definitely secure private network in the internet. So all encrypted communication, HTTPS and everything, all secured and safe. It's user-friendly management. It's very easy to set it, add devices, manage it, and even not devices, you can manage the networks. So it's centrally defined VPN topology, and obviously you have possibility of using the firewall and access control. Everything is in under your power, whatever you need to do. How it works? What's the basic principle of the WebAccess VPN? So it's as mentioned, it's encrypted communication, and actually there is a server, and between these two is established the VPN encrypted tunnel, and then the device communicate with the server via this tunnel. What we can see here is that you can connect the server multiple devices. So it's not the end-to-end for one device, but for multiple devices. Other thing is that each device get IP address, the fixed private IP address, which means that all the devices obtains addresses, but these addresses are not exposed in the internet. They are not shown to other users. So there is no unwanted traffic. No one sees these devices and not going to knock the door, which means the devices are not accessible from the public network. Now we come to the features. The first feature and advantage you have with the WebAccess VPN server is you can create the subnetworks. So the subnetwork concept for inter-router access control. You can create network 1, network 2, as we can see on the pictures, and into these networks you add the routers, the devices. The advantage is that you can at one device in both networks. So here you define that network 1 can access the network 2, but maybe cannot access the network 3. And the router, which is in the network 1 and network 2, can access another router. So this is how you can manage the networks, not only the VPN tunnels, but whole subnetworks. Another feature and mode is the one-to-one NAT mode. So LAN IP addresses here are translated to the virtual address space. And this means that actually we create the IP range when the physical devices behind the routers can have the same IP addresses. So here we see the router with 3 PLCs or some units connected to the LAN network, and these can have the same IP range, IP addresses as behind the physical devices behind this router. This can be easily used in a situation you have water treatment station or some utilities, and you have 30 locations over the country. And every setting of the water treatment is the same. There is security camera, there is PLC, there is a water pump, and in each network, the camera will have same IP address, 192.168.1.1. And the same in the second water treatment. The PLC will be 192.168.1.2, and the PLC in the second water treatment station will have exactly the same IP address. So then it's defined your network by the routers with different IP addresses, but the physical devices behind the routers are with the same IP address. This helps you, for example, to have easy overview of the whole topology, easy replicate and build new topologies, new networks, new plans. And also, if you get the information, the service guy gets the information, the security camera doesn't work, stop working, something happened, there can be one camera preset on the shelf with IP address 192.168.1.1, and you can use it in any of the water treatment plans. Obviously, there is access control, and you can play with the firewall rules. The firewall rules, they can be applied for the network and also on a device. So this is set independently on modes we use. The standalone VPN client is something you usually face and you see in like your daily operations, where we need to connect not only routers, but also other devices like SCADA servers, computers, tablets. So here you have the standalone VPN client you install on a SCADA server, on a tablet, on your computer, and you can connect these devices to the network. So then it's much easier to manage, monitor, and create the whole network. Other useful tool is direct access to the device web interface via VPN portal. How is it done actually? And when you can use it? Sometimes you have cases that behind the router you have the PLC, or it can be again camera or some remote terminal unit. And this PLC is from Advantech, from Siemens, from anyone you can picture, you can imagine. And you would like to provide, and it doesn't work or it doesn't behave as you want. You can provide, you can call the service guide, provide for them the link from WebAccess VPN, which provide the direct access via HTTPS URL, and the guy can access the device seeing the web interface. You can provide this access, this easy access, for 1 day or few hours. Whoever can do his job on the device, and then you just close this session or this connection. Independent management for each router interface actually means that I talk about two modes. So I explained the VPN public mode. We talked about one-to-one net mode. And there are two other modes. One is ignored, when this means that LAN is not managed at all, or another mode, it's a local only mode, when LAN setting is managed but the devices on this LAN cannot access the VPN. Very nice is that you can run all of these modes at the same time on one device. So here we have an example when the SmartFlex is connected to the WebAccess VPN server via VPN tunnel. And on each interface, you run different mode. So Ethernet 0, the VPN public, standard functionality. On Ethernet 1, you have local only mode, and which means LAN setting is not managed, but devices on this LAN can access the VPN. On a Wi-Fi, you have the ignored mode. And on a switch, on Ethernet 2, you have one-to-one net mode. What is also beneficial is the zero-touch centralized configuration. What this means that on your computer, when you see the WebAccess VPN web page, you can change the configuration of the router. You can change firewall rules, IP addresses. Once you have done this at your main screen, you just click, you just hit the enter, and all the setting is automatically transferred to the devices. Here, this picture shows actually what all we talk about, all the modes we can operate. So you can use it with your customer if you don't want to go step by step. You want to have big picture, and you want to talk about the standalone VPNs clients, about not one-to-one, and about the VPN public mode, the URL access you can provide for your service guy, the access for a few hours to the device in a local area network. You can use this nice slide which shows the whole functionality of the VPN secure tool. Applications, as you know, definitely remote access. So all the applications, when you do the predictive analysis and maintenance, you need to access any device, any server at the edge of the network for the application where you solve the overall equipment efficiency. Connection of the branches. When you have decentralized facilities. It can be kiosk, it can be operation. You need to have secured encrypted connection. This is the perfect way. And obviously, as we already mentioned, SCADA applications, the water treatment plants, and all the processes you need to control. We obviously look on competitors on the market and different solutions. And actually, what you see and what you usually find on the market is the companies, they focus on remote access because you need to solve the remote access, as we mentioned on the third slide, with when you have dynamic IP addresses and so on, you need to access it. Other companies, they went a little behind and they do like a software-defined WAN. What we would like to deliver to our customers is actually the remote access and also centrally managed VPN. What we mean by centrally managed VPN is actually that you here find that you can cover many applications you would consider as a software-defined WAN. The advantage I see here in this solution and what we discuss with our customers and partners, what they appreciate and what they need, is on-premise version. So we do offer on-premise version when the cloud service in our angle of view will be distributed, will be available, but only for the testing purposes. Also, we identify that and we understand that there are many applications, especially in energy, when you need to own the solution and you would like to have the box solution. Advantech, as the biggest manufacturer of industrial PC, is the perfect partner to host this solution on the PC. And if you need to connect more routers, you need to create more tunnels, you need to have more throughput, we can just easily go from basic Advantech industrial PC and we can use the Advantech server, the high performance Advantech server. So this is also on our roadmap, and this is what we're gonna sell. So here we are in a part when we talk about the ordering codes, and so far we have two options we can offer. And the option one is on-premise solution. Then the option two is image for the Amazon cloud. Both of these options, whatever you choose, number one or number two, have in a basic 5 routers. It comes with 5 routers and 2 standalone VPN clients. These are free of charge. So you can, for example, you can talk with Amazon, you can get an image from us, install it, and at the moment you have 5 routers and 2 standalone VPN clients you can play with. All the features are available. If you find that if you like it, you need to find more routers, more VPN clients, you have one of the options. You buy a license when we have license for 50 routers and 10 VPN clients, or for 500 routers and 50 VPN clients, or 5,000 and 100 VPN clients. From our experience, by these numbers, we are able to cover 90% of the applications. 90% of the applications use less than 5,000 routers. But even though if there is a requirement, if there is a bigger network, we can accommodate it and we can offer individual number of routers in one network. Also, big advantage is the free software updates for next 24 months from the time you buy the license. what routers we support and can be they can be connected to the WebAccess VPN. It's everything from our portfolio. So whatever the router you use from Advantech, you can connect with WebAccess VPN. Now something about the roadmap. So the release of version 1.0.0 is scheduled for August this summer. We also planned some future development, and on this future development is, for example, box solution we talk about, access the cloud version for testing purposes, and many others enhanced features. So this will be for now all, and now here is the part when we go the question and answers. So let's check if we have any questions.
Thank you, Pablo, for sharing with us the concepts and also features of WebAccess VPN. In the next section, Jen, the Director of Engineering, will be leading the Q&A time and answer the questions from all of you. Please type down your questions. We will start answering them very soon. So I believe that Jen is all ready for the questions, right? I see there are a few questions from the control list. Could you please help us? Yes, please help us read out the questions because people cannot see the control panel and then answer it. Thank you very much.
Yeah, sure. So the first question comes like this. What's the maximum number of router per client? Okay, I must think how to decipher this question. It maybe is rephrased in a wrong way. So I would answer what's the maximum number of devices behind router, because that makes more sense to me. You have seen that there is some numbering in place. Currently, we are using IPv4 with a space with the addresses starting with 10. So there is at the router, there actually can be connected 253 devices behind router that could communicate through the router to the VPN tunnel. So if I haven't answered the question, please rephrase it and ask again. Next question is what?
Maybe Jan, maybe this is also the question like what's the capacity? So like what we tested, how many routers we can accommodate on one VPN server.
Okay. So in that case, we are in the beta phase, and we did some preliminary testing, and we have tested between 1,000 and 2,000 routers, and the system was very fine. And we are now waiting to do more testing on stronger hardware. But the thing is that the limitation of the system is actually not a number of the routers, but more throughput of the system, because if you think that all the devices are communicating to a central point, you foremost need the central point with a good connection. Because if, for example, your link is 10 megabits per second, then this is your limit. So at the time of the release, we will publish both numbers achieved on which hardware, and also we will measure throughput and give out some numbers so that the customers can well see what's able to do on which hardware. So another question is about, what about ICR 1601? Okay, the ICR 1601 is running a different operating system, and at the moment is not supported in the WebAccess VPN as a router, which can connect devices behind the router. So that's because we are not using only the regular OpenVPN protocol, but we have something on top of OpenVPN, something which can be called like enriched protocol, which enables another functionalities than the regular OpenVPN. So what can be done at the moment, any device which is able to run a regular OpenVPN client can connect to the system as a standalone VPN client. So without the enriched protocol, but enough to be able to communicate with any device inside of the VPN network. So it's currently possible only via the standalone, only as a standalone VPN client. Another question is about pricing, so I will leave this one for Pavel. Okay, so I will go to another one and wait for Pavel.
I'm sorry, I'm here.
Yeah, sure. So the question was about pricing. Pricing, yeah, please. So, that's the actual text.
Yeah. So the pricing, obviously, we look at the market, what our competitors, what they do, and we try to align ourselves. So you can be sure that we are very close, and our offering is good. We will publish the pricing at the beginning of August, late July. The pricing for the 50 clients starts slightly over $1,000, but we will share the information when the time comes.
Okay, another question is, I suppose it's concerning the release. So it says 1st August or August 31st. So we don't say at the moment a particular day of the release. We just say it's in August because we are now in beta testing. We have passed alpha testing. We have fixed all what have we seen, and right now it's just about what more little features can we squeeze in the release, and what will be after the release. So it's basically August. I cannot say which. Another question: will we support WebAccess VPN on SmartSwarm? As far as I know, that's not on the roadmap at the moment, but probably know that we can react pretty quick on requirements coming from our customers. So I would say that if this surface as a significant requirement or request, it is possible. Another question. Okay, I will read it complete because it's a longer one. So it starts like this. WebAccess VPN, it reminds me of terminal server concept, except web server access, router, firewall, terminal server, internet. here, whenever a request comes to terminal server about pump data through SCADA, then terminal server routes the request internally to SCADA and get the information and send to the sender. So that's end of the question. I'm not sure. Okay, so I may somehow say what's the difference between terminal server and a WebAccess VPN. So the difference is that WebAccess VPN is here to basically create your internal network, which can, in a physical sense, be scattered all over the globe. So it brings you all the devices into one network, and the network is secure. So we are sure that nobody is peeking in. And then to the network, it can connect additional things like SCADA server, like monitoring device, and so on. And what does it bring is also a user-friendly setup, because your work with WebAccess VPN starts that you connect via HTTPS to a web user interface. And you do all the action inside a web user interface. So if there is a new router knocking to the WebAccess VPN, admin will see it in the web interface that there is some new router trying to access. And admin will decide if he allows or doesn't allow the new router to come into the system. And then, still in the web interface, he assigns the router and the devices behind router to the network, because there is the concept of subnetwork. So you can have more. You can have one, depending on your use case. And if the admin needs to access the router's web interface, he can do it. If it needs to limit via firewall rules, he can still do it. And another thing about firewall rules is that these firewall rules are executed on the VPN server, not on the router, which means that this is kind of central barrier, and it's independent on the local administrator of the router. So I would say that while you can do some fragment of the features using terminal server, you definitely can do something. There is a lot of features which will be from pretty hard to insane to do via a terminal server, and especially when it comes to bigger networks with bigger setup. So I will move to another question. Question comes like this. Do you require Windows Server to run VPN? So to answer this, the VPN, I would suppose that this will be the WebAccess VPN server. So the WebAccess VPN server runs on Linux only. It cannot run on Windows. So there are options. Pavel already mentioned. You can get it pre-installed on a box. You can run it in a cloud, like run the image. And basically, you can also do your own installation on a Linux server, but that requires some considerable knowledge. So I don't think this is way we will prefer to release. And as for the standalone VPN clients, this is only limited with the client you are using. So what could happen? I said that we support any VPN client. That's true, but we support a subset of ciphers, because some ciphers for encryption of the communication are not safe. We support only the safe ones. So it may happen that your software, your VPN client, doesn't know the ciphers, in that case, it doesn't connect. But there is no really limitation. So in the mode of standalone VPN client, any client that understands the ciphers can join. Obviously, you need the certificate first. So the certificate basically is generated on the WebAccess VPN. Then it's uploaded to the client, and then the client can connect. And the client obviously can run on the Windows server, no problem. Another question, comparison between using the WebAccess VPN, EdgeLink, and MQTT. I'm sorry, I cannot answer that at the moment because I'm not sure what is EdgeLink. So I don't know if, Pavel, you want to answer that. What I can do is to have a look outside of the time for presentation and send, put something down, send it out. Okay, another question. Free version will be downloadable from website. Well, downloadable. The WebAccess VPN must be running somewhere, and downloadable. You know, there are two things. One is the operating system, and second is the application itself. So basically, for testing out purposes, I would say the best way is to run an image in Amazon. Because this way, the image, when the image starts, actually, it will generate all the certificates, and you also will be able to import your own certificate and test anything you want. To install it on your own operating system will require some system knowledge. So this is not really a preferred way because you may be missing some libraries, some packages in the operating system, and it can be quite a tedious work to set it up. Another question, does MQTT and EdgeLink use less bandwidth than WebAccess VPN? Oh, it's another one I cannot answer at the moment because I don't know how much bandwidth is used in EdgeLink. What I can comment is that the WebAccess VPN actually set up the VPN tunnel, but and this setup can be quite consuming on system resources, but it's only setup of the tunnel. Once the tunnel is set up, the initial handshake between client and server is done, there is not really much information going through the tunnel unless the device is intentionally sending something. So looking at the bandwidth which is needed and don't looking at the setup phase, I would say there is not really extra bandwidth needed, if any, for the WebAccess VPN. You need to consider that all the traffic is encrypted, which means there is some cost on the CPU because it must encrypt and decrypt all the traffic. So another question, does the WebAccess VPN use more or less bandwidth than IPSec VPN? This is really complicated to answer because we are now comparing a solution, which is WebAccess VPN, with a protocol, because IPSec VPN is not a product. IPSec is protocol. So it should better be rephrased is OpenVPN using more or less bandwidth than IPSec. It depends, but the the option, there were two options when we were starting to think about a product. Either use VPN or to use IPSec. I would better leave the technical details for another like deeper level technical presentation, because this is not very deep level technical presentation today. But we chose OpenVPN because some how to say we had our reasons to choose OpenVPN, but basically the bandwidth is comparable between the protocol, between IPSec and between OpenVPN. There are not really like huge differences. So when you start to transfer considerable amounts of data, the protocols are almost equal. We chose OpenVPN because of other things than bandwidth. Okay, another question. What are the requirements of the VPN server, like hardware, operating system, network, etc., to run WebAccess VPN? End of question. Yeah, so what are the requirements? It's really tricky, because the answer is it depends on what do you need to do. If you just need to connect a few hundreds of routers which transfer only tiny amount of data, the requirements are like really small on the hardware. But if you plan on transmitting 100 megabits every second, then there are considerable requirements, because, for example, the CPU must be able to decipher 100 megabytes per second. And also the network must be able to sustain this amount of traffic every second. So it really depends on the requirements, on the use case. What are we going to do at the time of release? We are going to provide some measurements. So we will tell you this CPU can encrypt and decrypt that amount of traffic every second. We will also say that this and that number of routers can comfortably work with that and that hardware. As for the operating system, that's set. It's Linux at the moment, and it's not bound to a very well-defined branch or mark or of Linux. You can run it on any Linux, but at the moment we are focusing on Debian branches, because we build it as a Debian package, which means Debian, Ubuntu, anything like that. But in principle, it can run on any Linux. So another question, does WebAccess VPN allow to map dynamic IP address to static IP issued by carriers to SIM cards? E.g., do you require public static IP SIM cards from carriers to ping remote device from VPN server? The answer is no, because the device, the router, okay? So when the router starts up, it starts user module, and the user module connects to the WebAccess VPN server and establishes a connection. So the initial connection or the channel is established from the side of the router. Once it is established, communication can flow both ways. So we do not require any specific SIM card or public IP address. It's not required. So another question is, do you have any manual on WebAccess VPN? Yes, even at the moment, we have some preliminary documentation which we send to our beta test partners. It's not perfect, but as far as I've seen the feedback, it's enough to start experimenting with it. Together with the release, we will publish the documentation. Another question, any technical document like PDF on this topic? I'm not sure what does the question relates to, but if I can connect it with the documentation, yes, for the beta testers, there is documentation available, and the documentation describes basically two things or three things. So it describes how does a user use the WebAccess VPN. Then it describes the part from the router, how is it set up, and from another clients, the standalone VPN clients. And it also describes basic principles which are used. So it consists, I would say, a lot of documentation. And of course, there is a leaflet which you can download directly from the handout of the presentation right now. So that's all the questions I see. So I would give back to Pavel.
Thank you, Jan, for good answers. Thank you, everyone, for questions. Obviously, this was just basic introduction, and we will follow with deep technical level training session once the tool is released publicly and you can play with it. Kuei, thank you for organizing this session for us. If anyone has an additional question, please feel free to direct it to us, and we will be more than happy to answer it.
Thank you, Pavel, and thank you, Jen, for the non-stop 30 minutes Q&A and answer all the questions. As Pavel just said, if you still have any questions, please feel free to write us, to email us. We will answer it as much as we can. So it's the end of the WebAccess VPN webinar. Thank you all for joining us today. Hope we can see you online again in the next webinar next month. Have a nice day, ladies and gentlemen. Bye-bye.